you can kind of wrap your head around the fact that letters and symbols are actually numbers, you can actually begin to solve a lot of different problems related to strings in a way that's creative and very unique. What's up, guys? It's Taylor. Welcome back to The Blueprint, a channel in which we talk about software engineering principles and, sometimes I build things, but not today. Today is actually another episode of Good, Better, Best, our whiteboarding series here on this channel, in which I teach you guys how to solve whiteboarding problems in a way that's simple and easy for you guys to understand. As always, the timestamps are going to be in the description box below, and just let's get to it. So today's question is how to determine if all the characters in a string are unique. So let me give you a little bit of context for this. Let's take the word apple. A-P-P-L-E. There are duplicate characters within apple. There are two P's. But if we take the word orange, O-R-A-N-G-E, there are no duplicate characters. Therefore, every character is unique. How would you go about solving this problem? Now, there are several different ways that you could solve it. I'm going to show you three today. So our first solution is going to utilize two for loops. Our outer for loop is going to hold our position in our string, and our inner for loop is going to iterate through each letter of the string. So the logic that's going to be happening here is we're going to check each letter versus the preceding letters. So let me give you an example of this. Let's go back to our word apple. That A is going to be checked versus the first P, the second P, the L, and then the E. And that's one completed loop. Then our first P is going to be checked versus our second P, versus our L, and versus our E. And that's the second loop. And then the third loop would be the second P versus the L versus the E, so on and so forth. So you're seeing how each original letter is checked against the preceding letters. The logic behind this is as you check each letter, if the original letter is equal to one of the preceding letters, that means there's a duplicate within the string, and therefore all of the characters inside of the string are not unique. So let's see some code for this. So the first thing that we're going to do is to create that double nested for loop. In our first for loop, we are going to start at 0. We are going to terminate at the length of the string, and we're going to increment by 1. For our second for loop, we're actually going to start at I plus 1. The reason for this is because we do not want to repeat any work that we've already done. For the second for loop, the termination is also going to be at the length of the string, and we're also going to increment by 1. Now we have an if statement that is comparing to see if the char of the index of the outer loop is the same as the char of the index in the inner loop. If they are the same, that means that there are duplicate characters within this string, and that means that all of the characters within the string are not unique. In this case, I've decided to just use a simple print line statement to say that they're not unique, but feel free to return a Boolean or string value of your choice. So if you make it to the end of the loop and you never see a duplicate character, that means all of the characters within the string are unique. So I also decided to use a print line statement to also say, print out that this is unique. So all I'm going to do here is simply test our string. I'm going to use David with a capital D and a lowercase d because to a computer, these are different characters. And I'm also going to use David with two lowercase d's to illustrate this point. So our second solution is actually going to be utilizing the set data structure. If you're not familiar with the set data structure, essentially it's just a list that does not allow duplicates. So once again, let me give you a little bit of context here. If we try to add the word apple to the set data structure, every letter would not be added in there because there are two P's in the word apple. However, if we tried to add the word orange, the entire word would be able to be added to our set because every character is unique. So we're going to utilize this data structure to help us solve this problem. Here's the logic that we're going to use. We're going to create a for loop, and we're going to iterate over the entire string. Now, At each iteration, we're going to try to add the current character. If the current character is not allowed inside of our set, that means that the current character already exists within our set. Therefore, we have a duplicate and this string does not have all unique characters. So let's see some code for this one. So the first thing that we're going to do in solution 2 is to create an empty set. And once we have created our empty set, we're then going to go ahead and create a for loop. Our for loop is going to start at 0. It is going to terminate at the end of the string, and it's going to increment by 1. Now inside of this for loop, at each iteration, we're going to test to see if the letter is already present within our set. If the letter is already present within our set, that means that there is a duplicate in the string, and therefore all the characters in the string are not unique. If this is the case, I decided to use a simple print line statement to indicate that this is not a unique string. Consequently, if you get to the end of the loop and you never found a duplicate character, this is a unique string, and I also decided to use a print line statement to display that this is a unique string. In this case, I decided to use the two strings Amber and Asia to illustrate this method. Our third solution actually involves ASCII codes. And if you're not familiar with ASCII codes, let me provide a little context for you. Essentially, all of your letters, A through Z, and your special characters, @, exclamation point, question mark, can all be represented as a number. Let me give you an example of this. Let's use the letter A. Lowercase a is actually the number 97, whereas uppercase A is actually the number 65. So once you can kind of wrap your head around the fact that letters and symbols are actually numbers, you can actually begin to solve a lot of different problems related to strings in a way that's creative and very unique. But let's talk about how that relates to this problem right here. Essentially, what we're going to do is create an array that has enough space for 128 characters. Now, 128 is special because that is the amount of unique characters that are within regular ASCII. So essentially what we're going to do is iterate over our given string. Let's use Apple. And what we're going to do is at every single character, we're going to put a checkbox inside of their unique value in our array. If we were to use the word apple, we would put a checkbox in either 97 or 65, depending on if the A was capital or lowercase. And we would continue to do that until we got to the end of the string. What we would now do is check our array. We want to make sure that all of our boxes either have 0 or 1. If they have anything greater than 0 or 1, that means one of the letters inside of our array is going to be a duplicate, and therefore it's not a unique value in our string, or unique character for that matter. So let's see some code for this one. Solution actually involves ASCII codes. So we're going to create an array that has space for 128 boxes. Then we're going to create a for loop that starts at 0, that terminates at the end of the string, and increments by 1. So what we're going to check at each iteration is that the box that we're currently trying to put a check in needs to be empty, or it needs to be equal to 0. If it is not equal to anything else other than 0, or it is not empty, that means that our particular string has duplicate characters and is not a unique string. Once again, I decided to indicate this by using a simple print line statement and printing out is not a unique string. Consequently, if you get to the end of the loop and you never found any duplicates, or all your boxes were originally equal to 0 and now they're equal to 1, then you do not have any duplicates and your string is unique. Now, I decided to use the strings cookie and bread to illustrate this method. And just like that, we determined if all the characters within our string are actually unique. So I hope that you learned something from today's video and that you understood the different problem-solving methods we employed today. If you came up with a different way to solve the problem, or you just have some questions, feel free to drop them in the comments below. And I hope to see you around next time. Bye! Oh, you're still here. Didn't see you there. I guess you must have liked the video. And if you did, that's cool, that's fine, that's okay. Because I have more videos that you can watch. You know, if you were interested, you can just like totally click down here in this link that I'm sure is gonna come up pretty soon, sometime, any day now. It's gonna come up and you can totally click on that and look at some more videos in this series, or you could like subscribe if you wanted. That's cool too. Or you could do both. You know, I don't want to tell you what to do. You can really do both. You can really do whatever it is you want to do. We don't judge here on this channel. I'm just gonna go back to doing this.